This next one, let's do one at a time. Alright, so distance formula for 24, okay? And that's going to be -2 and 0, right? And 1 and 6, okay? Alright, -2 and 0 and 1 and 6, okay? Alright, let's think about this. The formula, I hit record, this is important. The formula is the distance is equal to y sub 2 minus y sub 1 squared plus x sub 2 minus x sub 1 squared, all square rooted. Now, just like slope. Remember how slope, I said flip it and smack it, right? Y sub 2 minus y sub 1 over x sub 2 minus x sub 1, right? That's the same as y sub 1 minus y sub 2 over x sub 1 minus x sub 2. Same thing. The only reason why mathematicians put it in this order is because 2 minus 1 is 1. And it gives you back, instead of getting a negative for a sub. Okay? A sub number. That's the only reason. There's really no reason. You notice the last formula we did was sub 1 plus sub 2. It went in order because it was plus. So with that said, you could also use this formula. Y sub 1. Well, I mean, you can even go as far as, what is x sub 1, but so y sub 1 minus y sub 2 squared plus x sub 1 minus x sub 2 squared. The whole key is that if this one is here, then this one is here. If this 2 is here, then this 2 is here. Okay? And that's why people with dyslexia can have a really hard time plugging into formulas. I have dyslexia. I have a hard time plugging into formulas. So I find an easier way to do it. Okay? And that's why I use what's called matrices. And in college I learned matrices that really helped me figure out how to organize my stuff a little better. And I used to teach matrices when I first started teaching. We don't teach it anymore. It's kind of weird. So we don't teach it anymore, but I teach what's called flip it and smack it. What flip it and smack it does is it organizes it. It organizes it because this is your x sub 1, this is your y sub 1, this is your x sub 2, this is your y sub 2. And so this organizes it. If I flip it, right, and put the x underneath the y's, because that's what I do with the slope, right? Slopes rise over run. So if I try to use the same thing over and over and over for multiple different things. Okay? So by putting the y on top and the x on the bottom, right? If I'm used to flipping it like that flip it just like in my slope, it keeps it in what's called a 2x2 matrix, right? It's nice, it's easy, right? And I don't have to worry about this number going into this one into that one, or whatever, because it's always backwards when they're doing it this way. It can be really confusing. If you take some of the confusing part out, so you just stack it up like that, flip it, boom, flip it, boom. Now it's really about the math. So the smack it, alright, that's just the negatives. Okay? That's just the two negatives in here. So I got a negative and I got a negative. And it's right top and bottom. And if you're used to me, this is how I taught it in Algebra 1 for slope, right? then by the time you get to distance, it's like, oh yeah, flip it, smack it, okay, and then rub it down. So you're used to doing flip it and smack it. It's like, okay, I can remember that. Rub it down, well, that's a whole new level. But what rub it down does is it makes me not have to remember the whole formula. I just remember, okay, rubbing it down. Okay, I remember when to rub someone down, you know. Rub it down is I've got two arms, right? Two arms, right? Okay, I got two arms. And they look like arms, okay? So I got two of those. And I got two legs, right? Okay? So I got two legs, right? I got one head, so that's a plus. You know, I had another head sitting here chatting at me. That would be kind of annoying after a while, right? So the one head is a plus. Okay? And then I've got the body, and the body is rooted to my legs and arms and my head. It's all part of the root. Okay? It's all part of the root. And so if you think about the body being part of the root, being part of the radical, right? Now all of a sudden, boom, and I've got distance. So I've got my two arms, my two legs, right? My plus, and then it's all held together by that radical. And now, when I'm on that state test, and I'm trying to remember that formula for distance that they don't give you, okay? It's a lot easier. Oh yeah, distance, yeah, distance, so flip it back, go up the down one, okay. I got that, I can remember that. The more you do this, because you'll have this on this test, you'll have this on your midterm, your final, your midterm next semester, your final next semester. So by the time you get to that test, you have hit this problem at least on 6 different tests, right? So I'm trying to just put it there in your head because it will be on that state test. I guarantee you, it always is. Okay. All right. So now it's the math. The math part is just 0 minus 6. That's negative 6, right? And then negative 2 minus 1 is minus 3. And the reason why this is always on the test is what's about to happen. You need to give me 2 things. You need to give me the exact number, and you need to give me the approximate number. Okay? So 2 answers for this, right? And what you have to remember is when you have a negative 6 squared, that's negative 6 times negative 6, that's 36. That's a positive. So it's always going to be positive. Distance is a positive. It's always positive. Okay? We don't think of things as a negative distance. I don't do a measurement on that wall or like on my kitchen and go, okay, the countertop is negative 33 inches. Right? I just don't, what? No, it's 33 inches from the wall. It might be this way, I might be going 36 inches from the refrigerator. Who knows? But I'm not going to be like, this is positive and this is negative, right? It's just distance. Okay? So this is going to be 36. And obviously this is going to be 9. Okay? And then 36 and 9, that's 45. Right? So we're at 45. Now, a lot of people would think, okay, then we're done. But we ain't done. We got to break this down. We got to simplify this. Now, I normally would have you be doing this, the steps, showing me all the steps. If you want to show the steps, I will give you extra credit on the test. If you do a 2-column proof for this, I'll give extra credit for that. Okay? And remember, how do you start out? Well, why is this like this? Well, because it's the distance formula. Oh, because means definition, right? Definition of a distance formula. Boom. And then everything else is just, I'm simplifying, right, with addition. Okay? I'm simplifying by squaring. I'm simplifying by adding. And now, I'm going to simplify the radical. Okay? I'm going to simplify the radical. What that means, this is what a lot of students have trouble with. Okay? And I created this upside down division for radicals when I was at the college. Because I had students who were like 60-some years old who hadn't had math since they were 6th grade. So I wanted to make sure I give them a way that's easy. Right? So we're going to use what's called prime factorization. Okay? 2, 3, 5, 7, 11, 13. Those are your main primes. Those should be in your cheat sheet. Okay? Those are your main primes. Okay? And you're going to use them to break this down. You ask yourself, does a 2 go into 45? Right? And there's 3 really easy problems. Right? 2s, 3s, and 5s. There's a trick to each one. How do you know if a 2 goes into a number? What's the trick? Come on, somebody got that trick. Huh? Not positive, it would be even. Right? Yeah, I knew. We were on the same level. Yeah. So it would be even. Is this even? No. It's an odd number, right? So 2 doesn't go into this. Okay? So what about 3? What's the trick for 3? Who remembers the trick for 3? Come on, Carlos. You had me. You know you heard this spiel before. What's the trick for 3? Teresa? Come on, someone. Trick for 3. Add up the numbers. What's 4 plus 5? Close. 9. It's early, I know. Alright, so 9, right? Is 9 divisible by 3? Yeah. So is 45. And that works for any number. If you add up the numbers and the number is divisible by 3, then that number is divisible by 3. Okay? And so the way my daughter does it, she goes, well, if you add them up and you just keep adding them up, like what if you get 12? And you add up 1 and 2, right? It would be 3. So what if you get like, a big long number, you get 26 or, 20, I don't know, like, let's go with like 27, right? You get the 2 and the 7 is a 9, right? So what she learned was, if you add up the numbers and it ends up being 3, 6, or 9, then it's divisible by 3. Does that make sense? It's just it just taught them to go a little bit further. That's what they taught her in like, I don't know, 4th grade. So what I'm trying to teach is, add these numbers, 4 plus 5, 9. 9 is divisible by 3, so we use 3. Okay? 3 goes into 4 how many times? Once, right? So the thing is that some people can see the 15, right? And then some people can't. So when you can't see how the number goes into it, use this thing called short division. I also made this up. Okay? Alright? Now, I use this technique's taught, but we use it for like LCM and stuff like that. Now, I use this method for everything. For factoring, for everything. I use it all the way through calculus, right? And the short division, same thing. 3 goes into 4 one time with 1 left over, right? And so now I have this 1 and this 5. And so it's really 15 right there. So I say, how many times does 3 go into 15? 5 times. And then I ask myself, okay, well, how many times does 3 go into, because does 3 go into 15? Yeah, because 1 and 5 is 6, right? So 3 goes into 15 5 times, right? Does 3 go into 5? No. So I move to the next one. How do we know 5 goes into a number? Because it ends in a 0 or a 5. So those are your 3 tricks. It's either even, you add up the numbers, and the numbers it adds up to be is divisible by 3, or it ends in a 0 or a 5. All right? Those are 3 easy tricks to remember. So we pull out the 5. I'm watching students. They're not doing this last step. You've got to go to 1. When you get to 1, you're done. All right? I try to make it easy. You know, it's all rhyming. Flip it, smack it, rub it down. Hey, you know, take it down to 1 and you're done. Okay? Try to keep things simple and rhyming so that you can remember it in your head. Okay? Now here's the key. You pick out your pairs. Okay? I got a pair of 3s. I circle that. And for every pair I circle, I take and I make one of them out of it. Now anything that's not circled goes back into the radical. Okay? Goes back into the radical. And that is simplifying the radical. The distance is 3 square roots of 5. Now, you'll go into your calculator and you'll type in the square root of 45. Hit equals, right? And that pops out a number. And this is the difference. Notice the difference here. This says equals. This is approximate. And symbols are everything in geometry. You have to use these symbols. It does not equal 6.7. It is approximately 6.7. Okay? Now the difference is, and I was using this with the students the other day, the difference in this is what you, in carpentry, right? In carpentry, we like approximations. All right? I just need to know how, you know, approximately. I don't need to know to the nearest freaking millimeter, right? It's like just closest 8. That's it. Not a nanometer, right? But when you're dealing with a rocket ship, chemistry, physics, right? Now you're talking about things that have to be a lot more exact. Okay? Depending on the process, depending on what you're talking about, if you're creating a telescope like the Hubble, that better be exact, as far exact as you can get. Okay? So that means you got to go out as many decimal places as you possibly can. And if you can use exact numbers like this, it's going to be so much better for you. Okay? Alright, so that's the difference between exact and approximate.